All right, so let's continue our discussion with solving systems of equations. Now, you'll notice here, at least I hope you notice, that we have a fun little square to deal with. So that's going to be super awesome. Now, it really doesn't matter which equation you choose or which variable that you choose to solve for. Now, I did it one way when I was first doing this, and then I did it a second way. Both ways are going to work. So tell you what, let's take this first guy right here, and let's solve this for y. So y would equal negative x squared plus 5. And then I can take that and plug it in down here. Now, the first time I did it, I solved the second equation for x, and I substituted that right in here. It worked out, but really both ways are going to be, you'll end up with the same result. So let's rewrite this. So we have x plus 3 times, and we're plugging in negative x squared plus 5, and this equals 5. Make sure that you are very careful about how you distribute. So it's going to be negative 3x squared plus 15 equals 5. All right, so we have something that's quadratic, so we're going to be expecting two answers here. Now, if I move the 5 over to the left and rearrange some terms, I would have negative 3x squared plus x, so it's going to be 15 minus 5, which is plus 10. And when it comes to factoring, you really want to make sure that the leading coefficient is positive. So let's change all of these signs. So positive 3x squared minus x minus 10 equals 0. So just take a quick little moment to see, if this is going to factor, do the AC method. So if I do a times c, that's 3 times 10, and that's 30. Are there factors of 30 that have a difference of 1? Yes, 6 and 5. So that means whenever I'm factoring this, I'm expecting to get 6 and 5 on the inside and outside pieces of the FOIL method. Well, 3x squared can only be 3x and x. And again, we're saying that we're going to use 6 and 5 here. Well, if I've got the 3, the only thing that I can make with the 3 is going to be the 6. So on the outside, we need the factor of 2. And then on the inside, we need the remaining factor of 5. So you can see here, you get a 5x and a 6x. Those guys will have a difference of 1. Putting the right signs means a plus 5 and a minus 2. And again, just take a quick moment to see. So you get plus 5x minus 6x, and that's negative x. So everything does check out. Now, finish solving this. So x equals negative 5/3, or from here, x equals 2. So it seems to be telling us that we have 2 points of intersection. We're going to check that with the graph here in just a moment, but let's look at the two possibilities that we have. Okay, so when I'm using x equals negative 5/3, I'm going to plug it into the expression we see there at the top where it says y equals. So y equals negative, parentheses, negative 5/3 squared plus 5. So this gives me a negative 25/9. And since we are dealing with fractions, let's go ahead and get the common denominator. So let's turn 5 over 1 into 45 over 9, and this gives us 20/9. All right, so I plugged in this value for x, and I get this value for y. Now if I look at the other one, if I look at when x equals positive 2, y equals negative, parentheses 2 squared, plus 5, so negative 4 plus 5 equals 1. So we plug in 2, and we get 1. So these are our two solutions. So let's just solidify that. So our solutions are negative 5/3, 20/9, and then we have the other solution, which is 2, 1. A much nicer ordered pair, right? All right, let's check our graph. All right. So in order to do this, we're going to have to solve each of these guys for y. So 5 minus x squared for the first one. And this other one, so it's going to be 5 minus x in parentheses because we have to divide the whole thing by 3. And let's graph. All right, so we do have our 2 points of intersection. I'm actually going to go to the table setup and have it do ask for independent and go to the table. So we're saying there was a solution when x equals 2. So if I hit enter, both y1 and y2 should be 1. All right, that is confirmed. And then the other one was negative 5/3. No, the answer is supposed to be 29ths, but it's not going to show us a fraction. So 20 over 9, if we just want to rewrite this, is 2 and 2/9, which is 2 point. So that's going to be 2 with a repeating bar. All right, let's see if that is correct. There we go. 2 and 2 with a repeating bar. Awesome blossom. We did it, guys. We did it. We're so special. All right, so there we go. We use substitution. Now, a little challenge for you. Suppose that you solved the second equation here, and you solved it for x. Can you still get the same answers? And I would say, yes, you can. Let's see if you can do that on your own.